Thank you very much for attending this session. We will gain some basic insights on moving average. Which one is more responsive to recent changes in actual data, and which one is trying to smooth out the data? A moving average with smaller number of periods averaged, or a moving average with larger number of periods. This is the data for a stock, and if I am asked which curve is actual, which curve is 5-period moving average, which one is 10-period, I first look for the one with maximum fluctuations, which is this one. What is the curve which its fluctuation is next to this one? That's it. So this is 5-period moving average. This is 10-period moving average. This is 50-period moving average. And this is 100-period moving average. The larger the number of periods in the average that we compute, the smoother. The smaller the number of periods, the more responsive to the recent changes. In this graph, the dark blue shows the actual data. The light blue is forecast. Suppose there is an unknown forecast which has come out like this. We want to compute MAD, mean absolute deviation. So we compute the gap between actual and forecast. That is the gap. The gap between actual and forecast. The gap between actual and forecast. And that is our deviation. In this graph, when actual is greater than forecast, I have painted red. When forecast is greater than actual, I have painted green, mainly because when actual is more than forecast, we have lost some potential sale. But in computing MAD, we give the same weight for the case when actual is greater than forecast and the case when forecast is greater than actual. And then we compute the average of these absolute values. Sometimes you can give higher weights when actual is greater than forecast, and try to direct your curve towards not to underestimate the demand and not to cause you to lose some sales. But as I said, in our procedure, we give the same weight to actual greater than forecast or forecast greater than actual. Which one is a better forecasting technique? A 2-period moving average, 3-period, 6-period, 12-period moving average? Which one is better? We don't know. The one is better, which minimizes our MAD. Here, I have compared 3-period forecast and 6-period forecast. Because we are talking about 6-period moving average forecast, therefore, I cannot start until period 7, because among 1 to 7, that is the only period when I have forecast for both techniques. And then I can continue this until period 12, because after period 12, while I have forecast for both techniques, but I don't have actual, I should compare the two techniques over this period. So this is forecast for 3, this is forecast for 6, this is absolute gap for 3, the gap between this one and this one. This is absolute gap for 6, the gap between this one and this one. Then I compute MAD. I average this one to itself, but I make the first one absolute, first row absolute here, and then I copy it down. And then I copy it down for this too. Now, if I compare these MADs, this one is lower. So 6-period moving average is better forecasting technique for this data. And then my forecast for next period is 1590. And my standard deviation of forecast is 1.25 multiplied by 190, which is 238. But For this set of data, if we go through the same computations, we see that this one is a smaller. So 3-period moving average is better for this specific set of data. And this is my forecast for next period. And this is standard deviation of my forecast for next period, which is 1.25 times this. Compute average and standard deviation of forecast for the next period using 5-period moving average and compute tracking signal. Let me open this file. 5-period moving average, I go to period 6, equal to average from period 1 to period 5, and copy down, and that is our forecast for period 13. Actual minus forecast equal to actual minus forecast, enter, equal to absolute value of actual minus forecast, equal to average of this to itself. But I put a dollar sign in front of the first 7 to make that one absolute and the second 7 relative. Now, if I copy these 3 down up to where I do have forecast and actual, both of them, I cannot come to here because here I don't have actual. And if I compute this, it is average of these numbers. And then I come here, equal to summation of errors without removing signs to itself. And then I put a dollar sign in front of the first 7. And then if I copy it down, here is the summation of all errors. And then tracking signal is equal to summation of errors divided by MAD. And that's it. What we know is if I'm using MAD, the standard deviation of forecast for next period is equal to 1.25 times MAD. So this is my forecast for next period, and this is standard deviation of forecast, and demand for next period has normal distribution with this average and this standard deviation. When we compute tracking signal, we think about an upper control limit and a lower control limit. In some books, it is written that they are between -4 and +4. This is incorrect. Based on your experience with your data, you may say it is +4 and -4. It is between these two, or plus, for example, 6 and -6, or +10 and -10. It depends on your experience with the data. Assuming that it is between -4 and +4 is not correct. So we want our tracking signal to remain between upper control limit and lower control limit. But what we really expect our tracking signals to be? Because it is summation of errors in the numerator and a positive number in the denominator, summation of errors, if we have a good forecasting technique, should be close to 0. So we want to see our tracking signal like this around 0. We don't want to see any pattern. If I see a pattern like this, what does it mean? Tracking signal is equal to summation of A minus F divided by MAD. And MAD is a positive number. So if it is like this, that means A minus F is negative. That means A is less than F. So we always have our forecast greater than actual, or most of the time. we are overestimating the demand. What is a situation like this? A minus F, which is in the numerator, is greater than 0. That means A is greater than F. Therefore, we are underestimating the demand. What about a situation like this? It means there is seasonality in the demand, and we have not included it in our forecasting technique. Or for no reason, we have included seasonality in our forecasting technique, but it does not exist in reality. A good tracking signal is something like this, which shows random variations around 0. For MAD, we compute these gaps. For MSE, we compute the square of these gaps. Therefore, MSE tries to not allow huge gaps between actual and forecast. So if it is a 3-period moving average, I go here and I compute the average of these 3 and I place it here. Then I find the gap between actual and forecast. The gap between actual and forecast and square it. This is this one. And then average these gaps, and this is my MSE. This is my forecast for next period, and my standard deviation of forecast is square root of this one, which is this one. So my demand for next period has normal distribution with this average and this standard deviation. This is for MAPE, or MALD, as I call it, mean absolute relative deviation, or mean absolute percentage error. It finds the gap between forecast and actual and divide it by actual. Gap between forecast and actual divided by actual. Gap between forecast and actual divided by actual. 2-period moving average as my forecast. 2-period moving average as this one. Absolute value of the gap between actual and forecast. Then we take absolute value of E and divide it by its corresponding actual. Take absolute value of error divided by actual value. Absolute value of error divided by actual value, and these are here. Compute average of this one to itself and average of all of this. If I multiply this by 1.25, I will get this one, and that is coefficient of variation of forecast. If I'm going to compute the standard deviation, I should multiply this coefficient of variation by this forecast, and that would be my standard deviation of forecast. A forecast for next period, which is indeed our average forecast, and also we come out with a standard deviation of forecast, which is either 1.25 times MAD, or is SQRT of MSE, or it is 1.25 times MAPE times forecast for next period. The 5-period moving average in month 6 was 200. The actual demand in month 7 is 170. Compute 6-period moving average in month 7. We have 5-period moving average in month 6, and we have data for month 7. Now we want to compute 6-period moving average in month 7. This is 5-period moving average in month 6. That is the formula. We add A6 to A2 and divided by 5. Here is 6-period moving average in month 7. We know that this part is common in both. So if I can use this equation and find these numbers, I can place it here, and then I have this one, which is over there, and then I can compute what I need. So I know 5-period moving average is equal to 200. Therefore, I can multiply this 5 by this 200 and get 1000, and that would be summation of these 5 numbers. Now I can put it over there, and I can bring this one and place it there. Then I can divide the summation by 6. This is 6-period moving average in month 7. I have all pieces. I put them together, and I compute it as 195. I could have done it in a different way. I could have said 5-period moving average in month 6 is 200. If this 170 was 200, then 6-period moving average in month 7 was also 200. But it is not 200, it is 170. 170 is 30 short of 200. And that 30 should be divided between 6 months. So 30 divided by 6 is equal to -5. It was 200. I need to subtract 5, so that is 195. This way or this way? I like this one better. You can stop me and spend 2, 3 minutes, 5 minutes to solve this problem. Exactly the same as the previous one. Now go to this one. This problem is a little bit different. 5-period moving average in period 10, and also 5-period moving average, not 6-period moving average in period 11. This is 5-period moving average in period 10. Summation of these 5 numbers divided by 5. And this is 5-period moving average in period 11. If we look at these two expressions, we see that the blue is common between these two. So if I can find blue in the first expression, I can place it into the second. It is easy to compute blue in the first expression because blue plus A6 divided by 5 is equal to 800. Blue plus 750 divided by 5 is equal to 800. And therefore, blue plus 750 is equal to 4,000, because we multiply this 5 by this 800, and that becomes 4,000. And then blue is equal to 3,250. Now I can take this blue and place it here. And I also have A11. 850 plus blue divided by 5, 850 plus divided by 5, which is 820. If I look into these formulas, I see this part is common. This one has a new part over here, where this part does not exist over there. So I can write that this is equal to this plus this part minus this part, and then divided by 5. 5-period moving average in month 11 is the same as 5-period moving average in month 10, but it has a new part and it has dropped an old part. And because this 5 is over there and this 5 is over there too, that would be the equation. Moving average, 5-period moving average in month 10 is equal to 850. What is 5-period moving average in month 11? It would be equal to this 850 plus the newest piece of data, which is 820, minus the oldest piece of data, which is 900. And because we are talking about 5-period moving average, they should be divided by 5. So that is 850 minus 16, which is equal to 834. We can also use solver to solve this problem. We know that in month 6, demand was 900. In month 11, demand was 820. We compute average for months 6 to 10, that is 5-period moving average in month 10, and then equal to average from month 7 to month 11, and that is 5-period moving average in month 11. But this 900 was indeed 850. We said 5-period moving average in month 10 is 850. So I go to data, I'll go to solver. I say, Mr. Solver, please look at these numbers, which I don't know what they are. But I know that this average here is equal to 850. Please change those numbers here such that this average comes out 850, and then I will know what is my average for period 11. Value equal to 850. Change these numbers. Solve. Those numbers are changed. Let's go to the last slide. Compute the age of data in 4-period moving average. In 4-period moving average, the newest piece of data is 1 period old. The second newest is 2 periods old. The oldest period is 4 period old, and 1 to the last period is 3 period old. So if you have 4 children, one is 1 year old, the other 2, the other 3, the other 4. On average, how old are those children? 2.5. But when we have a pattern like this, 1, 2, 3, 4, then we can just get the first one and last one and divide it by 2 and get the average. So here I can say 1 plus 4 divided by 2 give me the same 2.5. We can do this, or we can do this. But of course, this one is easier. 9-period moving average. The first one is 1 period old. The oldest one is 9 period old. Divided by 2 is equal to 5. Thank you very much for paying attention to this basic insights on moving average.